Okay, section 4, we're going to look at a new type of proof, and it is called an indirect proof. So we'll write algebraic indirect proofs, and we'll write indirect geometric proofs. So first thing, what is an indirect proof or indirect reasoning? A proof by contradiction. All three of these words kind of mean the same thing. They're all pretty much the exact same definition when you look at them. I like to use proof by contradiction because that's the type of indirect proof that we're dealing with. And you're going to assume the opposite of the conclusion as to what you are trying to prove. That's how you start it. Okay? And then you'll use your reasonings, what you believe is true, and then you'll eventually come across a contradiction that states two different things happening at the same time. And that can't happen. If I have two things stating completely opposites, then your original assumption was false. So I'll give you some steps as to how this works. Okay, so step 1. You're going to identify the conclusion of what you are trying to prove, and then you are going to state the complete opposite of whatever that conclusion is. So if I give you a conclusion that states a pen is red, you're going to state a pen is not red to get yourself started. Step 2, this is where you're going to use your logical reasoning. We've done a lot of that before using theorems, postulates, whatever that you need, definitions to state what you know is true. And then eventually what's going to happen is you're going to come across something that says something completely opposite of what you really want from your given. Okay, and then you just have to point out what that contradiction is in step 3. And we'll get into some examples as to what all of those look like. In example 1, we're just going to start out easy by asking you to identify the conclusion and then state the complete opposite of it. So example 1, state the assumption necessary to start an indirect proof of each statement. So in letter A, if 6 is a factor of n, then 2 is a factor of n. We know that the conclusion is always after the word then, so 2 is a factor of n. If I want to state the assumption, which states the complete opposite of it, instead of saying 2 is a factor of n, we're going to say 2 is not a factor of n. That's the assumption that you would start with. Letter B, if I say angle 3 is an obtuse angle, your assumption is going to be angle 3 is not an obtuse angle. Last one we'll look at is actually 1A. 1B is, instead of saying it is an equilateral triangle, we would say triangle XYZ is not an equilateral triangle. It's really no different than the ones from above. But for 1A, to state the opposite of saying something is greater than 5, the assumption that we would state is x is less than or equal to 5. Since I didn't have an equal to start, I have to disprove the equal to portion in my assumption, so we have to say is less than or equal to 5.